Okay, so now that we know basically how to write down our numbers, we know essentially where to put the digits, and based on what rules and regulations essentially the digits have to be put there. Meaning that, for example, a 12, I would write it this way, but then 100, for example, 120, I would write the same 12, then I put 0 over here. At 1200, I would write it the same 12, but then I put 2 zeros essentially in front of the number, and so on and so forth. That's basically how we write our numbers. Now we know this, and that's based on the place value, because of the fact that essentially over here we have the ones place value. For example, over here we have the tens place value, over here we have the hundreds place value, and over here we have basically the thousands place value. And based on these place values, we write our numbers, right? Now we can start doing different operations on these numbers. Now, for smaller numbers, you can essentially, you don't have to worry about these operations. Meaning that, for example, if you have a 9 plus a 3, then you know that essentially you have 1, 2, 3, 4, 5, 6, 7, 8, and 9 pebbles, or essentially 9 objects over here, and we have 3 objects over here, and we want to essentially, so this is basically a 9 and this is essentially a 3, and we want to add these together, right? So what I can do is that I can essentially the 9 basically the 9 pebbles, I can write it this way. So this is a 9, and then I take one of these and I want to put these together. So I take one of these and I make a group of 10, and then I have a group of 10, and then I have 2 left over here. So then I have one group of 10 and 2 groups of 1. So essentially I have the ones place value, I have the tens place value. So I have one group of 10 and 2 groups of 1. So essentially then I have a 12. So 9 plus a, which means that essentially 9 plus a 3 is equal to 12. And usually essentially we already know how to do this operation, so we don't have to use basically, I mean, from memory you know that essentially 9 plus a 3 is equal to 12. So usually essentially you just simply write your operation this way. You don't have to do anything else really. But there are circumstances where basically where you have, for example, when you want to do this operation 12 plus 53, right? Now this operation I can still do it in my head, for example, meaning that, for example, I know that I have 2 loose ones over here, 3 loose ones, so that's basically 5 loose ones together. And I have one group of 10 and 5 groups of 10, so that's 6 groups of 10. So 12 plus 53 would be a 65 basically. But then this is easy for essentially when it comes essentially to fairly small numbers, like for example 12 plus a 53. I can still do this in my head, although it would be easier for me to do this on a piece of paper, but still I can use the paper, but then I can simultaneously use my mind and do this operation in my head. But then there are operations like, for example, 255 plus, for example, 365, for example, something like that. And this gets a little bit complicated, meaning that I have basically five groups of 1, 5 groups of 1, then 5 plus 5 is equal to 10. So then that's 10 groups of 1, which is actually one group of 10. So I write essentially my place values over here, ones, tens, and basically hundreds. And so I have one group of 10, so I put the 1 over here. And then I have basically 6 groups of 10 and basically 2 groups of 10, so that's essentially 8 groups of 10. And then I have 1 group of 100 and 3 groups of 100. That's essentially 4 groups of 100. And we have no groups of 1, so I put a 0 over here. And so basically then I have, of course, these 2 groups, I have add them together. So I write essentially 4 groups of hundreds. 8 plus 1 is equal to 9 groups of 10, and then a 0. So that's essentially a 490. I hope that I haven't made any mistakes. So that's 125 plus 365. That's 490. Okay. Now you see that doing this kind of operation, even when you have a piece of paper in front of you, it's not very easy. Meaning that, and you might actually make some mistakes. So when it comes to this kind of operation, when it becomes a little bit complicated, then of course you need to do it in a way that you're not prone to making mistakes, right? In such cases, essentially what we do is that we write our numbers on top of one another, meaning that, for example, a 12 plus a 53, I write a 12 and I write a 53 over here, and I put the plus sign over here, and this is the ones place value, and this is the tens place value. Let me write this way. This is the ones place value, and this is the tens place value. And so now I know that I have 2 groups of 1 and 3 groups of 1. That's essentially 5 groups of 1. And I have 1 group of 10 and 5 groups of 10, so that's essentially 6 groups of 10. So a 12 plus a 53 is a 65, right? Now this was still not really necessary to do it this way. I could have done it in my head, really, and as I did so before. But then when it comes to, for example, when it comes to this calculation, I write 125 and 365. I put them together this way, and now I can basically, I can essentially add the numbers together. And of course, this is the ones place value, this is the tens place value, and this is the hundreds place value. So I have 5 groups of 1 plus another 5 groups of 1. That would be essentially 10 groups of 1. Now the problem is that I cannot write a 10 over here, right? Because we have the place value, and if you write a 10 over here, you would mess up essentially the place value in the number. So what I can do, essentially a 10 groups of 1, 10 groups of 1 is equal to 1 group of 10, right? 10 groups of 1, that would be 10 times 1 is a 10, and 1 group of 10 would be 1 times 10 is a 10, so it's the same thing, right? So then that means that essentially this operation, the way that I can write it in the number, the only way that I can write it in the number, I have to write it as 1 group of 10. So 1 group of 10 I'm going to write over here, right? And of course there is 0 groups of 1, so I put 0 over here, right? Now, because still I want to do the rest of this operation, meaning these groups of 10 are still there, what I'm going to do is that this 1, I'm going to put it over here. And that's the reason why we do the carryover in addition and subtraction and that sort of thing. Instead of putting the 1 over here, I put it over here. And now I can still do the rest of my operation, meaning that still I have 2 groups of 10, 6 groups of 10, that would be 8 groups of 10, and I had essentially 1 group of 10 coming from here, so that's basically 9 groups of 10. And then you can move essentially to the next place value. which is essentially one group of 100 and 3 groups of 100. That would be essentially 4 groups of 100, and that's basically how you can do your operation over here. That's a 490. So you see that this way essentially the operation becomes much more neat and much easier. I may do it one more time. So I have 125 plus a 365, and then I add them together. So then I have 5 plus 5 is equal to 10. So then essentially once we do the operation, we write a 10 as a 0 and a 1 carryover, and 1 plus 2 is equal to 3, 3 plus 6 is equal to 9, and then 1 plus 3 is equal to 4, and so that's a 490. So now the operation becomes much easier, and of course this way you're not prone to making mistakes, basically, right? Of course, the logic behind, for example, the carryover, you have to understand it. Meaning that over here we said that, for example, 5 groups of 1 plus 5 groups of 1 would be 10 groups of 1. But since I cannot write a 10 over here, then instead of 10 groups of 1, I convert it to 1 group of 10, and I put the 1 over here as a carryover. Yeah, you need to understand that, because otherwise you will not be able to understand, for example, long division. Later on we're going to do long division, and if you do not understand these carryovers that happen essentially in addition and subtraction, then you're going to be stuck in basically in long division algorithm, basically. Okay, so that's basically how we essentially calculate our numbers, meaning add our numbers. In the next video we will work a little bit on working specific cases with the Ginlary, and then out of the Ginlary we are eventually going to make essentially a number line, and then we will use it in order to do our calculations. Thank you.